Lecture 2 with complex analysis. Compute 3i squared multiplication 1 plus I equal, okay, distribute the square, 9 minus 6i minus 1 multiplication 1 plus I, which is equal 8 minus 6i multiplication 1 plus I equal 8 plus 8i minus 6i minus 6i squared equal 8 plus 2i plus 6 equal 14 plus 2i equal 14,2. Okay, this is method 1. Method 2, without I. 3 minus I multiplication 3 minus I multiplication 1 plus I equal 9 minus 1 minus 3 minus 3 multiplication 1 without I. Multiplication operation 8 comma minus 6 1 1 equal 8 plus 6 8 minus 6 equal 14,2. Two 1 minus 1 1 minus I. Okay, when the exponent is greater than 2, better we use the parentheses method without I unit. Okay. One minus 1 multiplication 1 minus 1 multiplication 1 minus 1 and 1 minus 1. Okay. Multiplication operation 1 minus 1 and minus 1 minus 1 1 minus 1 multiplication 1 minus 1 minus 1 minus 1, which is equal 0 minus 2 multiplication 0 minus 2 equal 0 minus 4 0 plus 0 equal minus 4 0. Okay. 3 minus 2i over 1 plus 4i squared Three minus 2i 3 minus, okay, without I need this 3 minus 2 comma 1 4 inverse square z1 over z2 operation, division operation. 3 minus 2 comma minus 2 1 over 17 minus 4 over 17 square the same 1 over 17 minus 4 over 17 square. Alright, equal 3 over 17 minus 8 over 17 comma minus 12 over 17 comma minus 4 over 17 minus 12 minus 2 pardon, I'm sorry for this, over 17 and 1 over 17 minus 4 over 17 minus 2. Alright, now equal minus 5 over 17 and minus 14 over 17, 1 over 17 minus 4 over 17, which is equal minus 5 over 289 minus 56 over 220 and minus 14 for 200. Alright, which is equal minus 61 over 289, 6 over the final answer. Alright, now relations on complex. Let Z belong complex. Then and so real part of Z or this equal real AB, which is equal A. Imaginary part of Z, which is imaginary part of Z equal imaginary part of AP, which is equal P. Okay. Example. For example, find real 1 plus I multiplication 3 minus 2I equal, okay, yeah, which is equal, okay, 1 3 minus 2 multiplication operation equal 3 plus 2 minus 2 plus 3 equal 5 1. Then the real part equal 5. Okay, Another example. Find imaginary parts 1/1 minus 3i 2 plus I. This is, for example, equal 1/1 minus 3, 1 minus 3, comma, multiplication 2 minus 2, 1, comma 1, equal 1/2 plus 3, multiplication operation, comma 1 minus 6, equal 1/5 minus 5. Okay, the imaginary parts 1/5 minus 5, of course, complete, equal 5 minus 5 inverse, equal 5/50, 5/50. So the imaginary part 5/50. Okay, page 3. Let's take identities of real and imaginary. Identities. Real, imaginary. Okay, algebra. One. Real Z1 plus or minus Z2, real part of Z1 plus or minus Z2, equal real of Z1 plus or minus real of Z2. This is the same for the imaginary part. Okay, proof. With left hand side, of course. Left hand side. Real xy plus AP for the 2 equal real x plus a, addition operation, comma y plus p, which is equal x plus a, real part. So real of Z1 plus real of Z2. Okay, but the same for the imaginary part, minus or plus. But real of Z1 multiplication Z2 equal real of Z1 multiplication real of Z2. False. This is false in general. Let's take counter example. Counter example. Okay, z1 equal z2, which is equal I. Left hand side equal real of 0, 1, 0, 1 equal real minus 1, 0, which is equal minus 1, real part. For right hand side, real of 0, 1, real of 0, 1 equal 0. Minus 1 does not equal 0. Does not equal 0. Okay, let's take example. Imaginary of 1 minus 2i, 1 plus 3i, 2 minus 5. Okay. One minus 2 multiplication. 1, 3, 3, 2, minus 5, which is equal multiplication operation. 1 plus 6, 3 minus 2, multiplication 2 minus 5 equal 7, 1, 1, 2, minus 5, which is equal multiplication operation 14 plus 5 minus 35 plus 2 equal 19 minus 33. Imaginary part, which is equal minus 33. Okay. Just I want to write something. Step 2. Step 2 is true if z1 and z2 are real, which is mean, okay, state 2, the state 2 is true if z1 and z2 are real, which is mean the imaginary part is 0. The imaginary part is 0.